Hi class, welcome back. Welcome back to my bunker where it is not too hot, not too cold, very safe, no coronavirus in sight. Anyway, I hope you're staying safe. Welcome back from Easter break. Hope it was everything you had imagined. I stayed home. Anyway, okay, so let's get going here again. Finish off this school year strong. Today we're going to do 12-3 trig functions of general angles. Okay, general angles, right? Common angles. Okay, so well, let's start. Let's do something else first. I've got a very old math joke for you. 5 plus 5 plus 5 equals 550. Thinking that probably doesn't look quite right, but the problem is I left off one little line. Okay, can you figure out where the little line goes? It's just one little line makes this sentence true. See if you can figure it out. I'll be back at the end of the video to point out where I made my omission. Okay, let's jump into it now. Okay, class, let's just jump right into 12-3. The main things we're going to learn today are reference angles and the values of sine, cosine, well, the 6 basic functions that we're going to be using. We're going to find their sign in the different quadrants, okay? We're going to use that to help us solve what could be more complex problems and just simplify them. Okay, so let's jump into the reference angle section. So, got my friend here, the Cartesian plane, and we've got the quadrants here. We've got quadrant 1, 2, 3, and 4. None of that's changed. You're used to seeing these. Not sure why, but they're always in Roman numerals for your viewing pleasure. I guess that since that's fairly unique, it kind of separates it from other concepts. Okay, so what we're going to do now is we're going to find out how to find a reference angle. Okay, so basically we're going to be using the two sides of the x-axis. We've got the positive side and the negative side. Suppose I got this guy here. This is a 120-degree angle. I'm thinking, what's the reference angle for this angle? Well, quite simple. I'm going to be looking at the positive x-axis and the negative x-axis. So this one's 0/360, and this one, of course, is the 180-degree mark. So if I have a 120-degree angle, I'm just going to take my 180, since it's on this side of the y-axis. I'm going to take 180 and I'm going to subtract 120 from it, and that will give me a 60 degrees. Okay, so the reference angle for a 120-degree angle is 60 degrees. And that's going to help me a lot because I'm going to use this chart over here, which, by the way, is a blue box of knowledge on page 562 in your books. We'll get to that later. But now we're going to find these reference angles, and we're going to label them like this. Alpha, it's a Roman, or one of our Greek letters, and alpha is equal to 60 degrees. That means the reference angle is 60 degrees. Okay, so that's over here, and we could see if we have a larger angle. Suppose we went down to somewhere around here. Let's call this 210-degree angle. Okay, so now I got to use a little common sense here. 210 is greater than 180, so I'm going to take this 210 and I'm going to subtract 180 from it, and I'll get 30 degrees. So in this case, with a 210-degree angle, the reference angle is 30 degrees, and that's this measurement right here, 30 degrees. Okay, so reference angles. Let's look at some over here on this side. Suppose I had a, well, let's clean this up a little bit first. Suppose I had let's call this a negative 27 degree angle. Okay, so it's negative 27 from the origin. So in this case, what we're looking at, we are looking at absolute values. Reference angles will always be positive, okay, because we're dealing with positive radii right now. So the radius will always be positive. We'll get to the negative radius. That adds a few more tricks, but we'll get there. For today, we're using positive radius. So with a negative 27 degree angle, basically I'm going to just take that 0.27, I'm going to subtract 0 from it, this being the 0 angle, and I get 27 degrees. So in this case, a negative 27 degree angle, the reference angle is 27 degrees. And it's already here. This is a 27 degree angle. And it's going to have the same characteristics as a 27 degree angle right there, with a few minor exceptions, which we'll deal with this table. Okay, that's all fine and dandy. What happens if we've got a humongous angle? Destroyed that. Suppose I've got let's go with a 453 degree angle. Ugly, really ugly angle, especially if I were trying to find the sine and the cosine using that size of an angle without a calculator. Okay, so what we're going to do, we're going to use some common sense once again. And the first thing we're going to do, if it's greater than 360, we're going to subtract a multiple of 360. And of course, those common multiples are 360, 720, 1080. You get the idea. You keep adding 360 all day long. Okay, so this one's going to fit nice and neat right within here. So I'm going to subtract 360 from it. And that will give me 93 degree angle. Okay. Passes the stupid check. Okay, so 93 degree angle. That's right. Well, it's probably a little sharper than that, but I know that it's over here in quadrant 2. Probably not quite as far into quadrant 2 actually, but that's okay. Okay, so since it's in quadrant 2, I know I'm going to use the negative side of the x-axis, or the 180 side. Erase my 180 there. Okay, so I'm going to just take 180 and subtract 93. And that'll leave me with 87 degrees, which is the reference angle of a 453 degree angle. So that goes right there, 87 degrees. So I can use 87 degrees as my reference angle for a 453 degree angle. Okay, so let's go way negative. Say negative 761 degree angle. All right, so again, reference angles are never negative. So we're thinking of absolute value, so we're just thinking absolute value here. And this one fits right in there, so I'm going to subtract 720 from there, and that ends up with a 41 degree angle. Again, don't yell at me about the negative signs. Absolute value, reference angles are always positive. Okay, so 41 degree angle. So let's just take a look at this 41 degree reference angle. Okay, so if I were to go negative 761, I'd be heading this direction. I'd go around once, I'd go around twice, and then I'd go another 41 degrees. So this right here, this is the negative 761 degree angle right there. Okay, so, but the reference angle is 41 degrees. So when I start figuring sine, cosine, tangent, all that stuff, I can actually use a 41 degree angle and use the values from a 41 degree angle with minor adjustments, which we're going to get from this table, to find those values rather quickly and easily. Okay, that's reference angles. So make sure you know how to find those. There's some exercises. We'll do a few for us. Okay, so let's take a look at a problem from the book. Excuse me here while I look at problem number 15. Problem number 15 asks you to find the reference angle if alpha equals -725. Okay. Very similar to what we just did. So for this number 15, -725 degrees. And we're looking for the reference angle. That's what they're asking us to do. So again, this is a negative angle, so it's going to go clockwise. I'm going to go around once, twice, and then some more. And I can see how much more by subtracting 720 from the absolute value of this. And that gives me a 5 degrees is my reference angle. So it's going to be 5 more degrees, which isn't much. But there is my -725 degree angle. But my reference angle is 5 degrees. So I can use a 5 degree angle for my reference angle for doing calculations. 5 degrees. Okay, so when I go to do some calculations, sine, cosine, tangent, the big 6, I can use 5 degrees for my reference angle. Okay, so that's that. Now let's get into some more of these problems. We're actually trying to find values, and we're going to take a look at this. Hey, let's take a look at this table here. This is the blue box of knowledge on page 562. Okay, what this helps us out here, if we combine it with these reference angles, in this case we have x and y are not equal to 0, because we can see if they were equal to 0 down here where tangent and cotangent are functions of sine and cosine, when we have one in the denominator, they would be undefined. And you can see that when you look at the quadrantial angles. Okay, so let's also r is positive. Again, we talked about that. We'll get into negative r's in a later lesson and learn how to deal with that. But for now, for this, we've got a positive r, and these are the values. We know that sine and cosecant, which is just the reciprocal of the sine, is positive in quadrants 1 and 2. And that makes sense because sine gives us the y value. Y value is positive in 1 and 2. So obviously the sine and the cosecant will be positive. And again, down here in 2 and 3 and 4, y value is negative below the x-axis. So they're going to be, of course, give you a negative value. And the same with the cosine relating to the x-axis. Over here, x is positive, 1 and 4. Bink, bink, all right? And then, of course, over here in 2 and 3, the x value is negative, which we get from the cosine and the secant. It's reciprocal, and so it's going to be negative over there. Okay, and with the tangent and cotangent, we know since it's either sine over cosine or cosine over sine, the tangent and cotangent functions, again, will be only defined when x and y are not 0. But if they're not 0, we know that if the signs are the same, then of course tangent and cotangent will be positive because we're dividing one by the other. Negative divided by negative gives you a positive. And then, of course, one positive, one negative is going to give you a negative in both of those cases in quadrants 2 and 4. Okay, that's that table. We'll be referencing that quite often here in the next few problems, what we're going to do. All right, stand by. Let me make some room on the board. Okay, as if by magic, the board is now clean. Okay, let's do problem number 44 right now. In 44, we're asked to find the big six, sine, cosine, tangent, cosecant, secant, cotangent, the big six, of a 480-degree angle. Okay, so this problem could be done by sticking it in your calculator. 480 sine, 480 cosine, 480, if your calculator's in degrees. Okay, that's nice, but what if you don't have a calculator and you want to know what this really means and how to get some deeper understanding? Okay, so in this case, we're going to use reference angles to find these values. And we're going to use this chart right here, knowing the positive and negative of each quadrant. Okay, first of all, let's draw this thing. 480-degree angle. So for this guy, I'm going to be going around once. There's 360. And subtract 360 off here, that leaves 120. Now I'm going to go another 120 degrees. Just about right there, give or take. Okay, so now that I'm over here, I see that I'm in quadrant 2. So quadrant 2, I know that the sine will be positive, the cosine will be negative, and the tangent, of course, negative, since there's a positive and a negative. And this I can tell. I really don't need to memorize this chart. I can actually look up here and think, okay, where is y? It's above the x-axis. So sine is going to be positive. Since I'm left of the y-axis, what's x value? X is going to be negative. So cosine will be negative. And since the tangent is sine over cosine, I have a positive over a negative, so I know that it's going to be negative. Okay, so, but for this particular problem, let's take a look here. Since I'm over here at 120 from the origin, we're going to be using the 180 quadrantial angle. So let's take 180 minus 120. That leaves us with a 60-degree reference angle. Reference angle is 60 degrees. That's this angle right here. 60 degrees. Okay, so now let's find our big six. Actually, I'll find 3, and you can find the other 3. I believe this is going to be one of our homework problems. Okay, so sine of 480. Since we know the sine is going to be positive, it's going to equal the sine of 60, which is what? Square root of 3 over 2. You should probably have these memorized for the 30, 60, and 45. If not, they're in a chart on in the previous section. Okay, and let's go with cosine this time. Cosine of 480. I know the cosine is negative since the x value is negative over here in quadrant 2. So I'm going to go the opposite of the cosine of 60. And the cosine of 60 is, of course, 1/2. But it's going negative because it's over there in quadrant 2. And then the tangent. Tangent of 480. I don't actually have tangents memorized, but they're easy enough to figure because it's just sine over cosine, square root of 3 over 2, divided by the cosine, which is a negative 1/2. And I multiply by the reciprocal, the 2's cancel, and that gives me a negative square root of 3. Okay, I'll let you find the cosecant, the secant, and the cotangent on your own. All right, let's do one more of these, and then I'll cut you loose to do your homework. Okay, let's take a look at problem number 47. In 47, they give us a couple of clues, and they want us to find the big six once again. They've already given us sine, so I guess we just need to find 5 more. And this is all the clues they gave us. Now, we don't even need to find the angle. We'll just use the values that were given in order to interpolate the other Okay, so they tell me that the sine of theta is -5/3. Okay, so first of all, I need to look over here at this table. If my sine is negative, that means I'm in either quadrant 3 or 4. So I'm either in quad 3 or 4. Okay, and they also tell me that the cosine is greater than 0, positive. So therefore, cosine greater than 0, I'm in either 1 or 4. 1 or 4. Okay, so that narrows it down. And down to quadrant 4 is where this particular angle has to be. So let's get rid of this. We use that to find out where we are. We are in quadrant 4. We are down here somewhere. I don't know where we are, but I know that we're in quadrant 4. Okay, so, but I do know what since I know what the sine is, I know sine is y over r. So since sine is y over r, that gives me a y value is, I could say, -5, because in quadrant 4, sine is negative, so y has to be negative. And that I also know that r is 13, since this is y over r. Okay, so I've got a -5 and a full 13. Now I need to find x. So if I can find x, I can write all these quite easily. So I need to find x now. So I know that r squared is equal to x squared plus y squared, because of Pythagoras. And I can move this around a little bit. X squared is equal to r squared minus y squared. And x is equal to plus or minus square root r squared minus y squared. Okay, so that's all I got to do is plug in r and y and I can find x quite easily. Okay, so we have plus or minus square root 169 minus 25, which is plus or minus square root of 144, which we know to be plus or minus 12. All right, but another clue here, plus or minus, which one is it? Well, we're in quadrant 4, so look over here at the cosine, positive 12, so x is 12. Okay, so now that I know x, y, and r, the rest of this is child's play. Quite easy to do. All right, so they already gave me the sine. Sine of theta is equal to -5/13. That's y over r. All right, cosine. Cosine of theta is equal to x over r, which in our case is 12 over 13. And tangent. Tangent of theta is equal to y over x. So in our case, -5 over 13. Okay, so there's problem 47 for your viewing pleasure. Okay, so I'll let you find the others. It's just the reciprocals. You know how to do that. You can do it in your sleep. Child of 3 could do that. So there we have it. There's today's lesson in a nutshell. Take a look at the example problems. If you have any issues, there's at least one for every section. So have a nice day. Oh, I forgot, I got to show you the answer to the quiz, or the puzzler, the math puzzler. Very old math joke. Anyway, see you later. Okay, I hope you found all that riveting. Let's find the answer to this here poultry dilemma that we have. I messed up and I forgot to put one line in here, just one little line. And let me show you where that line goes. It goes right there. There you have it. Makes that true. Anyway, have a great day, and we'll be back again soon. Bye.